Hi everyone, thank you so much for coming. We're Team Tricycle. I'm Fate. This is Jason, Caston, Eric, and Henry. You know that feeling you get when you're standing in front of a trash can and you're holding a coffee cup and you're not sure whether it's compost or recycling? Yeah, we get you. And that's why we're creating Tricycle, a self-sorting trash can. There are three main problems people face when they're sorting trash. One, apathy. We tend to throw away things without thinking twice about where it goes. Two, inconvenience. Maybe we don't feel like walking down the hallway to compost. And three, confusion. I'm a green advisor, and we're trained to teach people how to sort waste, and even I have trouble sometimes. This next graph shows you how important waste sorting is. The top bar is a breakdown of Swarthmore's current waste placement. The bottom bar shows you where we could be if everything is sorted correctly. In other words, a lot of what's going into our trash could have been composted or recycled. Our mission is to educate individuals about waste sorting, reduce waste management inefficiencies, and increase waste diversion away from trash towards compost and recycling.
And that's why we're developing Tricycle, a fully robotic, self-sorting trash can. You might have already seen our prototype in the Science Center, but that's just a sneak peek of what we're actually building. Here's how it works. Anyone places their trash here. We use cameras and sensors along with computer vision techniques to properly categorize the item. Our trash can then automatically rotates and places it into the correct bin. And finally, our touchscreen display shows the relevant categories, feedback, and stats. This addresses all facets of the problem from the user's end, like apathy, inconvenience, but most importantly, confusion. Now, imagine having a GA inside your trash can, actively helping you sort your waste and learn about how it's composted.
So let's talk about our value. We will target institutions as our primary customer to start because we are laser focused on their needs. Institutions can save a lot of money because recycling is about half the cost as trash across the US. Institutions also face large fines when they don't sort their waste properly, which Tricycle will do for you. We'll also track their statistics about their waste. So data is really valuable and important, and Swarthmore has told us that if they only had better statistics about their waste, they could negotiate cheaper contracts with their waste removal because the waste companies would know what to expect. They can also use our statistics to monitor their improvement as we help them reach their zero waste goals. Now, right now, if Swarthmore wants to know anything about our waste, we have to go outside and hand sort to see how well people are doing. With Tricycle, all of this is done automatically in real time. And we get to do all sorts of fun stuff with that data when you know which waste came from which bin. We also want to make a sustainability leaderboard, which would be displayed on the trash can, comparing us to our peer schools. We can harness the Swarthmore students' natural competitiveness for the good of the environment and finally beat Pomona, who's way ahead of us when it comes to sustainability. So, institutions make up 60% of our $75 billion waste management industry. And right now, Swarthmore College spends millions of dollars a year on waste management. And they spent $250,000 just buying new trash cans. These trash cans are big and they're in your face, but that's it. Our product blows that out of the water, doing way more for significantly less. And finally, our GAs on our team are the people actually building Swarthmore's next-gen sustainable waste management infrastructure. They built it. They know how it works. That's our insider advantage, and we're going to use that expertise that we've developed here, applying that to institutions across the country and around the globe.
We've been working super hard alongside the engineering department to prototype our technology. As of last week, we've set up a camera system within Science Center Commons. Just to be clear, this is only the camera half of the product. And right now, all we're doing is collecting data. We're asking the community to scan their waste in order to submit images to help train our machine learning algorithm. What we've seen so far, after 1,000 submissions, is that people get our product. They know what we're trying to do without needing one of us to explain it. We've seen people pull over their friends to show it off, and we even have a couple super users who try to scan as many items as they can. You might be wondering how the machine learning algorithm is doing so far. Well, I can tell you that within a controlled environment, we can achieve 85% classification accuracy. With all the buzz that we're generating with this prototype, we see all of this as hard evidence demonstrating the demand for our product. And now that we know that there's interest for it, the question is, how much does it cost to produce? Well, roughly speaking, there's two halves of the product. A visual recognition system, which we're calling the Smart Sign, and a robotic container section. We know their smart sign really well because we're prototyping it right now. We know we can acquire the components for $43. As for the robotic container section, our large size model, we can build that for $500, which we would then sell at the retail price of $19.95. Another core component of our business is an online subscription model. Our users are going to be able to opt in for tailored machine learning, as well as access to a data dashboard with detailed metrics and information about their current waste systems. Very recently, we've heard the Office of Sustainability vouched $3,000 for us to pilot our program through the Green Initiatives Fund. We're really excited to see all of this support. Let's stop waiting for the trash to sort itself and handle this in a smarter way. Thank you.